Today we're going to begin Chapter 4, and we're going to be looking at polynomial functions. Now here are some examples of polynomial functions. The top right is an example of a constant function. Then the top left is a quadratic, which we just did 2 chapters on. We learned how to graph and solve. Now look at the bottom left. That's a cubic. The exponent has a 3. And the last one, the bottom right, has an exponent of a 4. That's called a quartic. Let's go to the journal. We're now on the journal, page 78. Take a moment and copy down the definitions for polynomial, polynomial function, and end behavior. Now let's look at the core concept. Here in the core concept, we can see if the exponent of the function is odd, but the number in front is positive, the graph will look like the top left. If it's odd, but the leading coefficient's negative, it'll look like the top right. And then you can see if the exponents are even, what the graphs will look like. Now the portion that's dotted is we're not exactly sure what's happened in the middle, but we're sure of the arrows or the end behavior of these polynomial functions. Now let's go to our notes packet. Alright, so again, we're familiar with linear and quadratic functions. Let's look at this table here. If we have a constant function, for example, the function is just 2, the number 2, then the exponent is 0, because we basically have no x value. We call this constant, and we say the degree is 0. The next type of function we learn is linear functions. Notice the exponent here is 1. We call that a degree of 1, and we call these linear. Then we just finished testing on quadratics. That's when we have an x squared. The degree would be 2, and again we call this a quadratic. Next we could have a cubic, and it could have more terms. Let's say it could have a squared in it, but the highest power is what we're going by, and the highest power here is 3, so we call that a degree of 3, and we call this a cubic. We may also look at quartics, and that's when we have an exponent of 4. That would be a degree of 4, and again we call it a quartic. Let's look at example 1. In example 1, we want to identify if it is a polynomial function, and if so, write it in standard form. Tell me the degree, the type, and the leading coefficient. Looking at A, all the exponents are integer exponents, an exponent of 3, an exponent of 1, so that means yes, it is a polynomial function. To put it in order, you want to put it from highest power to the smallest power. It actually already is in order, so I'm just going to recopy it down. Next, state the degree. The degree is the same as the highest power, so the highest power is 3. If it's a 3, that means it's a cubic. The number in front of the x cubed is -2, and that's the leading coefficient. Let's look at B. B has an exponents of 3 and 4. So yes, this is polynomial. Let's put it in order. We have to put the greatest power first, so the square root of 2x to the 4th has to come in front. And then you can put the x cubed term and then the number without the x. Because the highest power is a 4, the degree is 4, and we call these quartics. And the number in front of x to the 4th is the square root of 2. That's the leading coefficient. Next, C. The exponents here are 2, -1, and 1. This would not be polynomial because the exponent is not an integer, not a positive integer. Let's look at D. This also is not a polynomial. We have exponents of 2 and an x in the exponent. That makes it not polynomial. Moving on to example 2. Here we're evaluating when x is 3. So that means we're going to find f of 3. This is a fancy way of saying just plug in 3 for all the x's. And then figure out this answer. So I plugged in 3 for all the x's, and now let's compute this. You could do it by hand or in calculator. Remember to do exponents first. 3 to the 4th is 81. 81 times 2 is 162. Exponents first. 3 squared is 9. 9 times 8 is 72. 5 times 3, and then subtract 7, and then go ahead and add these from left to right. After adding left to right, we get an answer of 98. Now let's look at example 3, describing end behavior. So you might want to make a little chart. If your degree is odd, that means the end behavior is going to be opposite of each other. So if our leading coefficient is positive, that means our graph will finish positive or up. And if the arrows are opposite, the first arrow must have been down. Now, if we have a degree of odd, that means the arrows are opposite. But if we start out negative, that means we're going to finish negative, and the opposite arrow would be pointing up. Now, for even degrees, the arrows are the same. So if it starts out positive, we're going to start and finish positive. If it's negative, we're going to start and finish negative. So let's look at the example. In our example here's our leading term. It's a 4th degree, which means it's even. And the leading coefficient is negative 0.5. That means negative. So in short, even means the arrows are going to be the same, and because it's negative, we're going to finish negative. So they're both going to be negative. Now to write that in proper terms, as x goes to negative infinity, that will be the left side, the function is pointing down, or negative infinity. As x goes off to positive infinity, that would be the second arrow. The function also is going to negative infinity. Notice, because it was an even function, the function's going in the same direction no matter you're going left or right. Now let's look how to graph polynomials. What we're going to do is 3 steps. First, let's decide the end behavior, or our arrows. Once you have your end behavior, you can draw that in and then pull up a table of values on your calculator. Go ahead and give me points from -2 to +2. Once you plot those points, and you know your end behavior, go ahead and draw a smooth curve by connecting those points. So let's try A. First, our leading term shows that it's a 3, or a cubic. And the leading coefficient is -1. So it's going to be an odd negative function. If it's odd and negative, that means negative we finish down, and odd the arrows are opposite. So we're going to put an arrow up on the left side and down on the right side. Now let's pull up our table of values using our graphing calculator. We're going to pull up points from -2 all the way down to +2. Those points are, here are our points. Now let's plot them. So what you're going to do is start at your left arrow and connect the dots from left to right in a smooth curve. And there's your graph. Let's try B. Look at the leading term. It's 4, so that means it's even. And the number in front is +1, so it's positive. Positive means we finish positive. Even means both arrows are the same. So they're both going to be up. Put them right about here in the middle of the graph. Now let's pull up our table and do values from -2 to +2. So I've pulled up my table of values. At -2, I'm at +12, which goes off the graph, so I'm going to skip that one. -1, +2. 0, I'm at 4. Then I have 1, 0, and 2, -4. Start at the left arrow. Continue to the first dot. Go to the next dot. Make sure you connect the dots from left to right. And that's it.
But it's all, like, it should be all one.
Yeah. I'm okay with one video too.
Yeah.